So this week we start the second quarter, and we start our second unit on volcanoes. I'll give you the unit outline tomorrow that goes over all of this. This unit outline that you get tomorrow has a lot more detail in terms of vocabulary than the other one did. So we're going to look at a couple of these words and ideas and concepts, and then we'll come back to the worksheet from yesterday, plotting volcanoes and where they occur. So first of all, pretty quickly here, let's just go over these words. You guys should know all these, right? A volcano is what? A volcano is? Yes. Okay. So it's a weak spot in the crust where magma and lava come to the surface. And as you guys mentioned, usually this is going to happen at plate boundaries. And as we'll talk about it, especially at subduction zones and divergent boundaries. Lava and magma erupt or come to the surface. And the difference between magma and lava, that's pretty easy, right? What's the difference between magma and lava? Magma and lava. Yes. Wait, which way is it? She knew that. I just asked it in the wrong order. So this is melted rock, basically in the crust or below the surface. And lava is the melted rock as it comes to the surface. Melted rock. And so, of course, we talked about this when we talked about igneous rock types, because if it's on the surface, it cools a lot more quickly, has smaller crystals, has air bubbles, all that sort of stuff. And the magma cools very slowly underground, making rocks like granite, and then you get the minerals forming in that. Granite, by the way, is an igneous intrusive rock. Many of you on the unit test said that granite was metamorphic. Granite is igneous rock. And so then the ring of fire is okay, it's the area around the Pacific plate. So it's a plate boundary. And much of this area is subduction zone, so there's a lot of volcanoes. Area around Pacific plate. Okay, then island arc. What was an island arc? Yeah. Good. So along the subduction zone, and we'll have the picture here in just a second, along the subduction zone, where that oceanic crust is getting pushed down into the mantle and being destroyed, it creates so much heat and pressure that volcanoes erupt on the surface. And because it's along the plate boundary, it's in a line or in a curve, so it makes an island arc. Along the subduction zone, volcanic islands, and we'll show you the picture here in just a minute. And then finally, a hot spot, as they just mentioned in the brain pop. What is a hot spot? What's a hot spot? Having to do? So a hot spot is a very active part of the mantle. They think there's, they call them mantle plumes, or there's convection currents in the mantle. At a hot spot, there seems to be a lot of activity, so much that it's actually making volcanoes in the middle of a plate. And the most famous one we know of is what? Hawaii. And as I said on the brain pop, it could be an active spot in the mantle. It could also be a weak spot in the crust. It might be a little bit of both. Very active part of the mantle, and it's basically um, making volcanoes, and it's not at a plate boundary. And so this is interesting too because in Hawaii, on the Big Island of Hawaii, which is, as I mentioned, it's the only state that the land is actually physically still growing. The volcanoes are still active, and it is the most active volcano in the world. It's been almost constantly erupting since the 1980s. Yeah, on the Big Island. Yeah, well, it's spilling out, and for years it was going down the side and then going into the ocean, and so you see these beautiful pictures of the lava going actually into the ocean. It's actually diverted and not going through there right now. But this is what we'll talk about tomorrow and the next day, the different types of volcanic eruptions. In Hawaii, you've got that runnier lava, and so it's not the big, dangerous, explosive eruptions. It's just constantly erupting. Yeah, well, actually, it's really interesting because yes, it's new land, but the other thing the eruptions have done is they have totally destroyed and wiped out this one subdivision. There was this whole neighborhood there, and little by little, the lava has kind of encroached, and it happens at a slow enough pace that the people could see the lava coming. Most of them evacuated their houses, and a couple years ago, like the last guy whose house was still standing, surrounded by lava. He finally moved out because the lava comes and it catches your house on fire and all burns up. But it's kind of interesting because you still own the land, but now it's a lava field, not, you know, the yard and that you once had. Well, you can sell it actually, but it's clearly not worth what it was before because before you had a piece of land on a beautiful island with an ocean view and trees and plants and all this stuff. And now it's a lava field. And I have some good pictures of it. It's actually really kind of interesting, but some of that land there is actually very inexpensive too because people are selling it because they own this was their home. This is I mean it's a huge investment of money and time. And now they have a piece of a lava field. And people are be, right. Well, it's going to take thousands of years, right? And you can go there and you can actually walk on the Chain of Craters Road and you can walk on the relatively new lava field. You can walk along where it used to be a subdivision. The lava actually went over the road, and so you can't drive there anymore, but you can walk on it. But even after, say, 5 or 10 or 20 years, you start getting little plants growing again. Anyways, it's really cool. So let's take a quick look here. Um, this is, of course, just Google Earth. But you can see here, this is the chain of islands. This is obviously the big island of Hawaii here. Let's make a color you can see. Yeah, so this is the big island of Hawaii. And the active volcano and the new stuff being laid down is here. And actually, if you see underwater, you can actually, so the Pacific plate is moving and the hot spot is staying in one place. These are the older islands. This right here, I believe, is Oahu, where Honolulu and the capital is. I think I think this one's Kauai. I get them mixed up. But then these are the older, tinier islands. And you can see, look at this whole chain of islands all the way going up here. So you can see this has been happening for years and years. Now, some of these are island preserves. One of them, like, used to have, it might still have, like, the Dole Pineapple Company owned one of these and had a whole plantation there. Um, but yeah, anyway, so that just shows you, you can see, though, the relief of that. You can see the topography of that happening there. Interesting, there is actually another hot spot we know of. It's actually happening under land, kind of lesser known. Yeah, well, actually, you wouldn't actually know it. The super volcano that is Yellowstone National Park, they think is a hot spot. So, yeah, that's Well, yeah, it could when and if it erupts, it's going to be a big problem. But I mean, the good news is, and we'll talk about this over the next couple weeks. Honestly, we are close enough to Yellowstone that if it has a massive, huge eruption, we probably won't need to worry about it because we'll be gone. But that's really, you know, no, we won't be fine. We'll be gone. We don't need to worry about it because we'll be gone. Yeah, we'll be wiped out, which is fine. I think I think it'd be better to go quickly than slowly. But anyways, um, but no, Yellowstone National Park, which is here, clearly it's right in the middle of the North American plate. But there does seem to be some hotspot activity there, causing the hot springs, the geysers, um, and the volcanic activity. But the thing is that I mean nobody knows. I mean it could erupt in the next 10 years. It might not erupt for 500 years. Either one of those is a very short amount of time in terms of geologic time. And you know, if it doesn't erupt for 100 years, which is not that long in terms of the history of the Earth, then it doesn't really impact us at all. Or 500 years. But anyways, we'll come back to that. All right, back to our volcano vocabulary. Okay, so we were talking about this, and again, this is the worksheet you, similar to the worksheet you were doing yesterday. So if you look at this, we have subduction zones. Actually, you know what, let's go forward and then come back to this. But all of these little triangles, and this is the picture in the book on, what page is that picture? Right there, ladies? 201. This picture is from page 201. And so you see Hawaii out here in the middle of nowhere. But this is the ring of fire. So you see all along here, this is a subduction zone. This is a subduction zone. You've got Japan here, Alaska. You guys did your earthquake projects. Biggest earthquakes, right? Chile, Alaska, Japan, big earthquakes. Also volcanoes in these same areas. And then Indonesia over here, but that's kind of broken up there. But this is the Ring of Fire, this very big, very active zone. Okay, and then over here, this right here is Iceland. This is the mid-Atlantic ridge, so this is the divergent spreading zone. And we'll have volcanic activity here. Most of that's totally underwater. However, in Iceland, that actually comes to the surface. All of Iceland is a volcanic island that is formed from these mid-Atlantic ridge volcanoes. Now, the really interesting thing about that, I don't know if you remember a couple years ago, the volcano in Iceland started erupting, and it created so much ash and dust in the air that basically all airplane travel in Europe was shut down for weeks because there was so much ash in the air. And it's so abrasive, so rough, that what happens is it would totally ruin the airplane engines and scratch up the windshields and stuff like that. So we'll watch a movie in a couple, probably later this week, and it talks about that volcano and a couple of the other ones. So here's what's happening. Again, the questions you answered yesterday, the worksheet you did last week. We've got the mid-ocean ridge. And again, this is where we've got new crust being formed, like we talked about before. And we've got magma. And so this is basically volcanic activity, pushing the crust this way. But that right there is a major volcanic, major cause of volcanoes. Then over here, as we talked about, we have the island arc. And what's happening here, the oceanic crust is being pushed down into the mantle. See, subducting plate. As it gets pushed down, it gets melted, it gets destroyed. That pressure that causes melting, causes heat, all of this. And then you get volcanoes here in a line. And then finally, that exact same thing can happen over here and make volcanoes. And Mount St. Helens, the Cascade Range in Northern California, Oregon, and Washington is volcanic because of this. All right. Then we have our hotspot in Hawaii. We've got the Pacific Plate moving over the hotspot. And so you can see, I mean, yes, it could be a weak spot in the crust, but the crust has moved all that distance, And so again, you've got the big island of Hawaii, you've got the hot spot, you've got new island being formed, and then way over here, oh, there you've got your names of the island: Hawaii, Maui, Oahu, Kauai, and then the littler ones way up here that are very old. Okay, that is the main. I'm going to skip that. That's the main part of that. All right, any questions? That's all section 1, plate tectonics and volcanoes. Everybody all good on that? The second part you read was the different types of magma, the physical and chemical properties of magma. As I've mentioned, as we go through this year, probably in April, you're going to be taking the standardized test for basically the TCAP type thing. It's now on computer, but it tests you over 6th, 7th, and 8th grade. So because it tests you over 6th, 7th, and 8th grade, we're going to talk about the different, we're going to talk a little bit about some of that 6th grade material.